Hello, this is Python from zero. Now we will see loops. So far we've seen variables which store data, conditions that make decisions. Now we make programs repeat actions. So let's get started. Let's open Google Colab. Let's delete the cell, which was from last. Let's print Python loops. The first time we run the first cell, it always gets connecting and it takes a little while, and that's it. Here we go. So why do loops exist? Without loops, repeating code would get ugly real quickly. For example, if we want to print something a few times, okay, so if we want to print it 5 times, we would do it like that. So this works, but loops exist so we don't repeat code manually. We'll look first at while loops. While loop repeats while a condition stays true. Let's do an example. Count equals 0. And then here's the while loop. While count is less than 5. And this is the same as with the if. This could be like this. So if it's clear to read, well, this condition evaluates to true, well, this true, then do what's indented, like if. So we're gonna print Luffy. If we did this, it would run forever. Let's see what happens. This will make my computer probably stay like this forever, or crash, or I don't know. So now it screams at me. Keyboard interrupt. Prints by, I don't know. So then why did it do this? Because, well, count is less than 5, do this, but count is always 0. So this is the most important part about while loops. We need to increment or decrement dependent of our if. Now, every time we run this, while this is true, print Luffy, and then make our variable count be set to whatever was the actual value plus 1. So 0 plus 1, so it will store count. So let's just for good measure print count. See? First printed Luffy, then made count 0 plus 1, so now count is 1, so then prints count, so 1. And then the next time around 2, 3, 4, 5. So since it was equal to 5, we got to here again. Is count less than 5? No, because it is equal to 5. So then we got out. So let's unindent and then print we are out of the loop. Here, 1, 2, 3, 4, 5. We are out of the loop. So just to iterate, make this point important, on while loops, the most important part, or a very important part, is the incrementing the value, or if you are doing this the other way around, count equals to 5, And then while count is, I don't know, let's say bigger than 0. And then count equals count minus 1. So now 5, and then it would make this 4. So, and then 3, 2, 1, 4, 3, 2, 1, 0. So depending on how you look at this, this is a very important line on while loops. I guess they are called loop counter. Loop counter, loop counter, loop counter. Now we will look at another type of loop, which are called for loops. I think these are a little bit cleaner in the way they repeat a fixed number of times. Let's do an example. For I in range 5. So this is a little more magic syntax, I think, but it's cleaner. This does the counting for us. So let's run this. Here we go. Sort of 5 times because it's easy. We placed here a number 5 and it did what's indented 5 times. So like before, just to make this clear, let's print the I. This can be named whatever, no? Counter. Zero. Oh, this is important. In programming languages, and I do not know why, but almost in all of them, or a lot of them, the ranges, counters, every time we start to count, the first item is a 0, not a 1. Go figure that out. Or there must be some logic behind it because everything inside is zeros and ones, right? So anyways, this range function, which is built into Python, returns an array, a list, from 0 to 4. So it has 5 items, 1, 2, 3, 4, 5, from 0 to 4. Let's do a little experiment. Just some variable equals to range 5, and then we are going to print some variable. Printed range 0, 5. Some variable. Same. Now let's print type. It's an object of class range. So this returns an object, which is an iterable. All right, so that's it. So back to the regular for loop. Also, since ages ago, it's common practice to when the iterable is just for counting, we're not going to do anything with this. A lot of programmers use I, J, and K. Sometimes even this, if we are not going to use it, right? It still works. Okay, so back to the loop. There is a special syntax for these for loops, which is called break. So the break immediately stops the loop. Let's say we break here. Printed one time and then immediately broke out of the loop. Now let's nest this break inside an if statement. If I equal auto-completed the example. I guess a lot of people use this example, right? So for I in the range 5, print Zoro. But if I, again, we could set this in parentheses if it makes reading it easier. If this condition evaluates to true, then run what's indented. Run this block. So what the blocks do? Break. So what would you think it will do? This is important, right? So we might have thought it would printed it 3 times, but no, because remember, here sorry, this will only be run in the last one. Let's place it here. There we go. So 0, 1, 2, and then when the value of I, it was actually 3, we run that 4 times, 0, 1, 2, and 3. Okay, so on to the next example. There's another keyword for using on the for loops, which is the keyword continue, which skips the current iteration. So it's like if then just skip it and increment and run it again, but now with the next number. So we skip 1. Let's do an example. Okay, so we are in the basic example. Print I from 0 to 4. Now, let's do this. If I equal to, it knows what I'm gonna do, equals to 3, equals to 2. So when I equals to 2, it will just from here go back to here. So it will not run the block. I was gonna add another like this, print I, print, so whatever we're gonna print in right here, no? The whole block, which is now 2 prints. 0, Zoro. 1, Zoro. 2, when this is equal to 2, we just go back to here and then continue. All right. So we can also have nested loops, one loop inside the other. That's what I mentioned, the I and the J. For I in range 5, do this block, and then inside this loop for j in range 5, then print I comma j. There we go. So this starts at 0 and then runs this block, right? 0, 1, 2, 3, 4. When this loop ends, it goes back. So it's like finishing the block. So then we start this upper loop again. So then this becomes 1, and then we start the inner one again. 0, 1, 2, 3. So let's do a little example using a while loop for what it actually might be used for in a real piece of code somewhere. Password equals to empty string, then while password not equal to meet print so remember, input is a built-in Python function that prompts the user for an input. We type the password, it will prompt for a password. So whatever we type, it will be assigned to the variable password, and then it will evaluate this. So while true, it will keep prompting. So until this is false, so when the password is the real password, this will evaluate to false, right? Because meet not equal to meet, false. Meet is equal to meet. Okay, so let's run this. Password. Nope. Password. Password. Nope. 1, 2, 3, 4. Nope. Until we write meet whom? Access granted. Okay, so I think that's it for this video. Thank you for watching. See you in the next one.